Now we're looking at using scatterplots to identify relationships. So recall that scatterplots represent two variable data as points. Scatterplots may reveal a relationship between the two variables. So in two variable situations, one variable may be dependent on another. That means its value changes according to the value of the independent variable. For example, the value of a car depends on its age. So if we were to graph this, our independent variable, which is the age of the car, that would usually be along our x-axis. And then the dependent variable, the value of the car, would be plotted using our y-axis. So typically we plot the independent variable on the horizontal axis or the x-axis and the dependent variable on the vertical axis. Next thing you should be able to do is interpret a scatter plot. Mike researched estimates for a job painting his house. The scatter plot shows Mike's results. Which is the dependent variable? Justify your choice. Recall that the dependent variable is usually placed along the y-axis. So in this example, the dependent variable is cost. And why does that make sense? Well, we can assume that employees are paid for the time they work. So the cost depends on the time required for the job. B. Which company will take the longest? So if we look across our x-axis, we see that company D and company E take the longest time for the job. Which company is the cheapest? If we look along the y-axis, we see that the lowest point is point E. So company E is the cheapest. Which companies charge the same amount? So if we look here, both company B and company D charge the same amount. And E. Why would you choose company B over company E? So you can see company E takes a long time but are the cheapest. Company B takes less time but they only cost a bit more. So you might pick company E if you're not in a hurry. They take a long time but are the cheapest. Or you might pick company B if you want the job done fairly quickly but economically. So next we're going to look at types of correlations. A correlation is a relationship between two variables. The first type is a positive correlation. Both variables increase together. So we see as the independent variable increases, the dependent variable increases. So on a scatter plot, the points go up to the right. Then we have a negative correlation. One of the variables decrease while the other variable increases. So as your independent variable increases, your dependent variable is decreasing. And on a scatter plot, the points go down to the right. So let's take a look at a scatter plot. So for example, Davis conducted an experiment comparing a person's leg length and how long it takes the same person to walk 100 meters. He gathered the data shown here. So you can see on the right we have a table with leg length in centimeters and time in seconds. Alright, so let's graph the data. First we need our x and y axis. Our x-axis will be our leg length. And our y-axis will be our time. Next we're going to put breaks in this graph, both along the x and along the y, because we see that our smallest number here is about 62, Our smallest number here is about 50. Our largest number for the time is about 83. And our largest leg length is also 83. So if I want to go from, let's say, 60 to 82 for the time, we're going to start off at 60 because that's our lowest. And let's count by 5. So there's 60, 65, here's 70, 75, 80, there's 85, there's 90. So that should fit all our data points for time. Next is our leg length. So we're going to start at 50 because that's close to our lowest number. This time I'm going to count by 3s. So the next one will be 53, then 56, 59, then 62, 65, then 68, 71, then 74, 77, then 80, 83, then 86. And we see that this will cover all our leg lengths along the x-axis. So next we start by plotting points. So our first point is 80 and 66. So we go over to 80 along the x, and we try to get close to 66 along the y. So there's our first point. Then we go to 73, 74. So 73 along the x, and 74 along the y. And then continue graphing the points from there. Alright, so now we have our scatter plot, and you see we have, as the leg length is increasing, it appears that the time is decreasing. So recall that we call this a negative correlation. So let's answer the following questions. So B, does this graph suggest a relationship between leg length and time taken to walk 100 meters? And we've already answered that question. The points go down to the right, so this suggests a negative correlation. The time taken to walk 100 meters tends to decrease as the leg length increases. So C, use the scatter plot to estimate the time it would take a person with a leg length of 85 to walk 100 meters. And explain. So if we go up to our graph, we need to find a leg length of 85. So that's here, 81, 2, 3, 4, 5. Right about here. And all we would do is draw a line up, and then we'd say, well, maybe if we were following the trend here, that maybe a time of 60 seconds might work. And right now it's just a guessing game. But later on we'll look at how to do lines of best fit and how to approximate it a bit better. So we estimate that it would take a person with a leg length of 85 centimeters 60 seconds to walk 100 meters. How might Davis make the results of his experiment more reliable? 1. He can collect more data. And 2. He could recruit people with a wider range of leg lengths while keeping other factors such as age, gender, and body type very similar to see if there's a pattern. Alright, last thing. You should take a few minutes, read and make notes about cause and effect found on page 141 of your text, and then read through example 3 on pages 141 to 142. And once you've done that, complete the following questions.